Today, we're going to meet what might just be the weirdest nerve in your entire brain. Seriously, it's this tiny, overlooked part of our anatomy that seems to break all the rules. And its story, well, it really shows you just how bizarre and brilliant our bodies can be.
So let me ask you, what is the weirdest nerve in your brain? You might be thinking of one of the big ones, right? The famous ones. But I'm willing to bet the true champion of strange is a nerve you've probably never even heard of.
Okay, just get a load of this little oddball. It is a walking contradiction. First off, it's the smallest cranial nerve if you're counting the number of nerve fibers. But even though it's tiny, it takes the absolute longest road trip inside the skull. And then there's its path. It is the only nerve that decides to leave from the back of the brainstem, the part connecting your brain and spinal cord. It's like it's sneaking out the back door while everyone else uses the front. And to top it all off, it's the only one that crosses over to the other side. It controls a muscle on the opposite side of the body from where its control center is. This nerve doesn't just break the rules, it totally rewrites them.
So this little bundle of contradictions has a name. Meet the trochlear nerve, otherwise known as cranial nerve number 4.
All right, so with all those strange characteristics, you have to wonder, what is this nerve's actual job? Let's take a closer look.
Despite all its unique quirks, its mission is incredibly, almost ridiculously focused. It has one and only one job, to control a single tiny muscle in your eye called the superior oblique. That's it. All that weirdness, all that complexity is for just one muscle. Controlling just one muscle might sound simple, but how it controls that muscle is a little marvel of biological engineering. And to understand it, you really just have to think about a simple machine, the pulley.
The name trochlear isn't just some random, complicated medical term. It comes directly from the Latin and Greek word trochlea, which literally means pulley. The nerve is actually named after the little structure its muscle uses, which acts exactly like a mechanical pulley for your eyeball.
So how does this pulley system work? It's actually a beautifully simple 4-step process. First, the trochlear nerve fires off an electrical signal. That signal makes the superior oblique muscle contract. But here's the really clever part. Instead of pulling straight, the muscle's tendon loops through that little fibrous ring, the trochlea. This pulley redirects all the force, causing your eyeball to rotate down and inwards. It is the exact, precise movement you need to do things like read a book or walk down a flight of stairs without tripping. So we know its job now. But to truly appreciate this nerve, we have to follow its absolutely bizarre journey from deep inside the brain all the way to the eye. Okay. So the journey starts deep inside the midbrain, but right away, it does something strange. It crosses over, the technical term is decussates, switching to the total opposite side of the brainstem. Then, while every other cranial nerve is exiting out the front, this one, again, sneaks out the back. From there, it begins its marathon, taking the longest path inside the skull, wrapping all the way around the brainstem before it finally reaches the eye socket to do its one very specific job. Now, this weird crossover isn't just a fun fact. It has a huge real-world consequence. Because of that twist, the location of an injury changes everything. If the nucleus, that's the control center inside the brainstem, gets damaged, it's the eye on the opposite side that's affected. But if the nerve itself, the cable basically, gets damaged after it has left the brainstem, it's the eye on the very same side that has the problem. For doctors, this little quirk is a vital clue for pinpointing exactly where the damage is. So what happens when this tiny, overachieving nerve actually gets damaged? What's the real-world impact? Well, simply put, you start seeing double. When that really elegant pulley system fails, the superior oblique muscle just can't do its job of rotating the eye down and in. The eye begins to drift upwards, and the result is a condition called diplopia, which you and I probably know better as double vision. But this isn't just any double vision. It actually comes in 2 very distinct forms. With vertical diplopia, one image appears higher than the other one. To compensate, people will instinctively tuck their chin down, which helps realign their vision. Then there's torsional diplopia, where the world itself actually seems tilted. To straighten it out, a person will tilt their head to the opposite shoulder, which rotates the eye just enough to fuse those 2 images back into one. This combination of a chin tuck and a head tilt creates a very characteristic look. In some older medical texts, the trochlear nerve was sometimes called the pathetic nerve, and this specific posture led to doctors describing a dejected or kind of sad appearance in their patients. So why does this amazing little pulley system break down in the first place? And how do doctors diagnose such a specific, tiny problem?
Well, the causes usually fall into two main buckets. For an acute or sudden palsy, the most common cause by far is head trauma. Because of that long, thin path it takes, the nerve is just really vulnerable to being stretched or damaged, even in pretty minor accidents. Now, for chronic, long-term cases, the most common cause is actually a congenital defect, something a person is born with. And often, these are so minor that the body just compensates for them for years and years, and they only become a real problem in adulthood when those compensatory tricks just start to fail.
So, how is a problem with this one specific nerve actually tested for? Well, it all comes back to the muscle's primary job. Since the superior oblique is working hardest when you look down and in, doctors will test that specific motion. And this is the exact movement you use for everyday things like reading or walking downstairs, which is why double vision during those activities is often the very first sign that something's wrong.
And to officially confirm the diagnosis, doctors use a specific maneuver, and it's called Bielszowski's head tilt test. It's designed to completely isolate the function of that one muscle and prove that it's the real source of the problem. So there you have it, the trochlear nerve, the smallest but with the longest intracranial journey, the only one to come out the back and the only one that crosses over to control the other side. It's a tiny underdog with a huge, precise job. It really makes you wonder, doesn't it? What other unsung heroes are working inside you right now?